Okay, let's have the continuation of our discussion. So now we're going to solve for the solution of oblique triangles. Okay, so by the definition, again, oblique triangles are the triangles that have no right angles. Okay, as a standard notation from our earlier discussion, we have here the angles labeled as ABC, and their opposite sides are small letter or the lowercase letter ABC. Okay, so when to use the law of sines and when to use the law of cosines. Okay, so earlier we discussed about the determination of the triangles depending on its sides and its angles. So for the laws of sine, what are the cases to consider? We have here the two angles and any side, AAS or ASA, ASA or angle side, or you can have the angle side angle. And then for B, two sides and an angle opposite one of them. So side angle. And then for the law of cosines, when the given is three sides. Okay, the side. And then we have here two sides and their included angle, angle, side. So let's start first with the first case for the law of sine, which is angle side or angle side angle. So let's have an example. First off, we have here the problem. Solve the triangle ABC given that we have side A is equal to 62.5. Angle A is 112 degrees 20 minutes and angle C is 42 degrees and 10 minutes. Okay, so if we will have its illustration, we have here the side A is 62.5 units, and we know the angle A is equal to 112 degrees 20 minutes and angle C is 42 degrees and 10 minutes. So the missing sides are B and C, and we don't know also angle B. So from this figure, notice that we can have here two angles and one side. So this is angle side, or we can have the side angle. Okay, which will qualify to the law of sines condition. Okay, so in identifying the length of B, we know that the sum of the angles of a triangle is 180 degrees. So all we need to do is to subtract the sum of angle A and angle C to 180 degrees. So 180 degrees minus the sum of the two angles. So given that, we'll have 180 degrees minus 112 degrees 20 minutes plus 42 degrees 10 minutes. And the result of that is 25 degrees and 30 minutes. Okay, so we have now the angle B. So for the side B and side C, we need to use the law of sines. For B, let's use the sine A over A is equal to sine B over B. Okay, since we have the sine A, we have the angle A, we have the angle B, we have the side A. Then we can identify the side B here. So as we substitute that, we'll have this equation. B is equal to A sine B over sine A. If we are going to identify the side B. Okay, and that is 62.5 sine 25 degrees 30 minutes all over sine 112 degrees 20 minutes. So if we will use the calculator, the value of that is 29.09 units. So therefore, the side B here is 29.09. And then for the side C, we can use again the law of sines, wherein we have sine A over A is equal to sine C over C. So we have here angle A, angle C. We have the side A. So all we need to do is to identify the side C. So by manipulating this formula, we'll obtain A sine C over sine A. As we substitute its values, we have 62.5 times sine 42 degrees 10 minutes all over sine 112 degrees 20 minutes. And if we will use our calculator, we type this, the result of that is 45.36 units. Let's have another problem. Okay, so let's say we have, for the case of angle side angle. So given that triangle ABC, we're going to solve for the angle A, side B, and side C. So we have here angle C that is equal to 115 degrees, angle B that is 30 degrees, and angle A is 30 centimeters. So if it will illustrate that, we have here the side A as 30 centimeters, and the side C is obtuse, which is 115 degrees, and the side B is 30 degrees. Now, for the angle A, so again, this is angle side angle. For the angle A, all we need to do is to subtract 180 degrees to the sum of angle B and C. Okay, so that is 35 degrees. Because 30 degrees plus 115 degrees is 145 degrees. So 180 degrees minus 145, that is 35 degrees. So we have now the angle A. And then for the side B, we can use again the sine A over A, sine B over B. Okay, since the given here is the angle A, we have now the value. The side is available is side A, and then we have the angle B. So we can obtain the side B. So again, manipulating that, we'll obtain this. And then let's substitute. So 30 times the sine 30 degrees all over the sine 35 degrees. So as we substitute this, we'll obtain B, the side B. And that is 26.15 centimeters. And then for C, same procedure, sine A over A is equal to sine C over C. So with that, we can obtain, again, the side B. So manipulating this, we'll obtain this one, A sine C over sine A. And then substituting again, its values, we'll have 30 times the sine 115 degrees all over the sine 35 degrees. And the result of that is 47.40 centimeters. So you can use the calculator to evaluate this. Now, let's have another condition. Use the law of sines when given two sides and an angle opposite one of them. So side angle. So here, actually, this is an ambiguous case because it could be the given cannot form a triangle, or it can form two triangles. So we need to consider the following cases. Okay, so this is the ambiguous case. So let's start first with case number 1, given that our angle A here is acute. So focus on here, these four figures here. Okay, so let's start first with if A is less than H. So here, uh, you need to identify the height. Okay, you need to identify the height to evaluate to know if there is no triangle or one triangle or two triangles are formed in the given problem. Okay, so if the side A is less than to its H, then it means there's no triangle exists with these dimensions. Okay, so take note of that. If A is between H and B, okay, then two triangles exist with these dimensions. Okay, so let's look at this one, the fourth figure here. So as you can see, if A is greater than H and less than B, then we can say that this forms two triangles. Okay, there's two possible triangles. Okay, and then another case, in addition with that, one with angle B is acute and the other one is obtuse. Okay, in addition, if B is between H and A. So B is greater than H, less than A. Then one triangle exists with these dimensions. Okay, and also, if A is equal to H, then we can say that one triangle exists. Okay, but we know that angle B here is a right angle. So if A is equal to H, remember that one triangle exists and the angle B is a right angle. Okay, so remember these four cases, then we will use it later to solve the oblique triangles. And then, in addition, how about if the angle is obtuse? Okay, angle A is obtuse. So we have two cases here. If A is less than or equal to B, look at the fifth figure here. If A is less than or equal to B, then no triangle exists with these dimensions. But if A is greater than B, then one triangle exists with these dimensions. So remember, if the angle given is obtuse, we have only two cases. It's either no triangle exists or one triangle exists with the given dimension. Okay, for us to understand this, let's have an example. So given a triangle with A is equal to 120 degrees and A is equal to 22 centimeters and B is equal to 15 centimeters, find the other dimensions. So here we have angle A as 120 degrees, which is obtuse, right? Which is obtuse. So we can identify the two cases. Right? From the two cases of case number 2, we will compare the side A and side B. Since side A is greater than the side B, which is 22, is greater than 15, then we can say that one triangle exists with the dimension. Okay, from the previous slide, we identified if A is greater than B, then there's a one triangle exists. Okay, from the given dimension. So from that, let's illustrate. So let's say this is triangle ABC, and then we have the sides A, which is 22 centimeters, side B, which is 15 centimeters, and then angle A is 120 degrees. Okay, so for us to identify for the angle B and angle C, again, let's use the concept of the law of sines. So for B, since we have a given here for angle A and side A, and we have the side B, then we can obtain the angle B by this. So here we have sine B is equal to B sine A over A. So by manipulating this, we'll obtain this one. Okay, then let's substitute the given. So we have here 15 sine 120 degrees all over 22. Okay, so to identify the angle B, let's have the inverse. Okay, so B is equal to the inverse, sine inverse of this. Okay, which is 15 sine times sine 120 degrees over 22. Okay, so if you will input this in your calculator, you'll obtain 36.2 degrees. Okay, that is 36.2 degrees. Okay, since we have now here angle B, angle A, we can use again the fundamental principle that the sum of the three angles is equal to 180 degrees. So if we will apply that, let's substitute A as 120 degrees, B as 36.2 degrees. So 180 degrees minus its sum, angle C is equal to 23.8 degrees. Okay, so now in our solution here, you can explore the laws of science, not just by the fundamental principles, but you can also use some other way. Okay, just remember if it should have the needed uh, information such as the sides or its angles. Okay, so now for the C, let's have here the sine A over A is equal to sine C over C. Okay, since we have now the angle A, we have the side A, and we identified the angle C, we can obtain now here the side C. So we have this formula as we manipulate that. C is equal to A sine C is equal to sine A. Okay, then as we substitute, that is 22 times sine 23.8 degrees all over the sine 120 degrees. And the result of that is 10.25 centimeters. Another example. Solve the triangle ABC given that C is equal to 628, B is equal to 480, and angle C is equal to 55 degrees 10 minutes. So check the angle. Here we have the given 55 degrees 10 minutes, which is an acute angle. So therefore we will consider the case number 1. So there are 4 conditions there. Okay, so in order to evaluate, to identify the number of triangles exist in this dimension, we need to identify the height. Okay, so in order to identify the height, all we need to do is to have this B sine C. So as you can see here, we have the B, which is 480, and then our angle is 55 degrees 10 minutes. So 480 times the sine 55 degrees 10 minutes. Okay, and if we will solve that, we'll obtain 393.99 units. Okay, so comparing that, we have the height of 393.99 units, and then we have your C as 628, and our B is 480. And here we can have B is between the H and C. Okay, so from this condition, if you will look at the 4 situation earlier, we can say that there is one triangle exists with these dimensions. Okay, since B is greater than the height but less than the side C. So if that's the case, we have here one triangle, triangle ABC, and we know the sides B 480 units, side C as 628 units, and then we have the angle C, which is 55 degrees 10 minutes. And then for the angle B, that's all for the angle B. So for the angle B here, we have sine B over B is equal to sine C over C, since we have the given angle C and side C. So from this, let's solve for the angle B. So in solving this angle B, we have your sine B is equal to B sine C over C. Okay, then let's substitute the side B, side C, and angle C. So we have your 480 times sine 55 degrees 10 minutes 620 all over 628. Okay, then again inverse. Okay, to identify the angle B. So we have your sine inverse of 480 sine 55 degrees 10 minutes all over 628. Okay, then you can use your calculator. Then you'll obtain 38 degrees 51 minutes. Okay, for angle A, let's use again the principle that the sum of all the 3 angles is 180 degrees. So let's add angle B and angle C. So that is 38 degrees 51 minutes plus 55 degrees 10 minutes. Okay, 180 degrees minus the sum of that, and the result is 85 degrees 59 minutes. For the side A, okay, so for the side A, we have again the angle A, and then provided that we have the angle B and the side B. we can use this. Or you can use also the sign, the C. Okay, it's your freedom since the angle C and side C is also given. Okay, so you can use that also. So manipulating this formula in order to identify A, that is B sine A all over sine B. So substitute the given 480 sine 85 degrees 59 minutes all over sine 38 degrees 51 minutes. And the total of that is 7 hours. The result of that is 763.32 units. So therefore, the side A here is this one, 763.32. Let's have another example. So solve the triangle ABC given that A is equal to 10, B is equal to 15, and A is equal to 40 degrees. Okay, so as you can see here, we have two sides again and an angle. So if that's the case, we need to test if this dimension exists in a triangle. Okay, so since we have here a 40 degree as our angle, so it's an acute. So we will consider again case number 1. So let's check again. Solve for the height. Okay. So as we solve for the height, that is B sine A. So B here is 15 and sine 40 degrees. So if you will calculate that, 15 sine 40 degrees, the result of that is 9.64 units. So we need to compare the H, the side A, and the side B. As we compare the 3, we can have A is greater than H but less than B. If that's the case, there are two triangles that is possible in this dimension. So with that, we will have the two illustrations for the two triangles. Okay, so let's solve first the angle B. Okay, let's solve first the angle B. Since provided that we have angle A and angle B, angle A and side B. So for angle B, we have this. So in order to solve for angle B, again, let's manipulate the formula. And as we substitute the given, 15 sine 40 degrees all over 10, we'll use again the inverse, okay, to identify the angle B. So angle B here is sine inverse of 15 sine 40 degrees all over 10. So if you will calculate that, the result of that is 74.6 degrees. Okay. Now, since there are two triangles, one is obtuse, one is acute. So since we solve here angle B as acute, let's have the obtuse angle. So in order to obtain the obtuse angle for angle B, let's have the B prime is equal to 180 degrees minus B. Okay, so we need to subtract that 180 degrees to the angle B that we obtained here. So that is 180 degrees minus 74.6 degrees. That is 105.4 degrees. So again, there are two triangles exist in this dimension. So therefore, we have here angle A as 40 degrees. And then our angle B here is 74.6 degrees. Okay, so remember this one is 74.6 degrees. So angle A and angle B is are both acute. But here, if we will form this triangle, angle A is 40 degrees and angle B prime is obtuse. So in constructing this, we'll have this one. Okay, angle A again is 40 degrees and then angle B prime is 105.4 degrees. Okay, so we have two triangles and we have two possible solutions. Okay, so we will solve for the remaining sides and angle that is missing. So first off, let's have for the angle C. and angle C prime for this figure. So for angle C, all we need to do is to add that 40 degrees and 74.6 degrees, and then subtract again 180 degrees minus its sum, that is 65.4 degrees. So angle C here is 65.4 degrees. For the angle C prime here, same procedure. So add that 40 degrees and 105.4 degrees. So we'll obtain 34.6 degrees. Okay, so here the angle C prime is 34.6 degrees. And then we have now the side A, side B. So all we need to do is to identify the side C. And here the side C prime. Okay, so for the C here, again, let's use the concept of the loss of sign, which is sine A over A is equal to sine C over C. Okay, and then finding for the side B, manipulating this, will obtain A sine C all over sine A. Then substitute the given, we'll have 10 times sine 65.5 degrees all over the sine 40 degrees. So if you will calculate that, you will obtain the value of C, which is 14.16 units. For the C prime, same procedure, just substitute the given. So here our sine C prime, which is 34.6 degrees. Okay, so we'll have 10 times sine 34.6 degrees all over the sine 40 degrees. So if you will calculate that, you will obtain the C prime as 8.83 units. So as you notice here, we have two triangles formed, so therefore there are two possible solutions here. Okay, we have here the angle B, angle C, and side C. In another case, we have the B prime, C prime, and the side C prime. Now, we are done with the laws of sines. How about the laws of cosines? So for the law of cosines, let's start first with the three sides. Okay, given the three sides, let's try to identify all the angles. Angle A, B, and C. So given that we have A is equal to 25.2, B is equal to 37.8, and C is equal to 43.4. So we have the triangle ABC with its sides. So for us to solve for angle A, angle B, and angle C, we need to use the cosine law. Okay, we need to use the cosine law. So for angle A, if you will manipulate and identify for the angle A, we'll have cosine A is equal to B squared plus C squared minus A squared all over 2BC. Okay, so all we need to do is to substitute this. We have 37.8 squared plus 43.4 squared minus 25.2 squared all over 2 times 37.8 times 43.4. Since we are after with the angle A, we'll use the inverse, cosine inverse of this one. And then if you will calculate, you'll obtain 35 degrees, 19 minutes. Same procedure for angle B and angle C. So just use the cosine law, then manipulate it. For B, we have cosine B is equal to A squared plus C squared minus B squared all over 2AC. And then if we substitute the given, again, the sides here, 25.2 squared plus 43.4 squared minus 37.8 squared all over 2 times 25.2 times 43.4. And then since we are after with the angle B, again, inverse. So calculate that. And the result for angle B is 60 degrees, 7 minutes. Okay, so for the angle C, you can use the fundamental principles. Just subtract 180 degrees to the sum of this. Or you can use, again, the formula. Okay, such as this one. Okay, the cosine C is equal to a squared plus b squared minus c squared all over 2ab. Okay, so if you will manipulate the law of cosines from our derived formula earlier, we will obtain this. Okay, then let's substitute the sides. So we'll have 25.2 squared plus 37.8 squared minus 43.4 squared all over 2 times 25.2 times 37.8. So again, use the inverse to identify angle C, and the result of that is 84 degrees 34 minutes. So if you will add this 3, the total of that is 180 degrees. Okay, so that is for the 3 sides. Now, how about if we have 2 sides in an included angle, side angle side? Let's have an example. Solve the triangle ABC given A is equal to 132, B is equal to 224, and C is equal to 28 degrees 40 minutes. So here we have our illustration. Let's have a triangle ABC. And then side A, side B, and angle C. So we have side A 132 units, side B as 224 units, and our angle C is 28 degrees 40 minutes. So this is side angle side. Okay, side angle side. So we'll use the cosine law for this. Let's identify first the side C. Okay, so for the side C, just the formula. Okay, just substitute it to the formula. C squared is equal to A squared plus B squared minus 2AB cosine C. So let's substitute the sides, and it's angle C. So 132 squared plus 124 squared minus 2 times the quantity of 132 times 224 cosine 28 degrees 40 minutes. So again, you can use your calculator to solve this, and you'll obtain the side C. Okay, so remember, this is a squared. So you need to square root the result of this. Okay, this is a squared. So again, you need to square root the result of this. Okay, and that is 125.35 units. And then for angle A, so same procedure from the earlier example. So we have here cosine A is equal to B squared plus C squared minus A squared all over 2BC. So all we need to do is to substitute the 3 sides. Okay, just substitute the 3 sides that we obtained. Okay, that is 224 squared plus 125.35 squared minus 132 squared all over 2 times 224 times 125.35. So again, since we are after with the angle, all we need to do is to have its inverse. So cosine inverse of that, and use your calculator to obtain the angle A. And the result of that is 30 degrees 21 minutes. For angle B, again, you can use the cosine law, manipulate that, or you can use the fundamentals, the sum of the angles of the triangle is 180 degrees. Okay, so it depends on you. Okay, so if you will use this, substitute again the 3 sides, and then get its inverse. Okay, cosine inverse of 132 degrees plus 125.35 squared minus 224 squared all over 2 times 132 times 125.35. And if you will calculate this, you will obtain the angle B. And the angle B here is 120 degrees and 59 minutes. Okay, so if you add the 3 angles here, the total of that is 180 degrees. Okay, so that is for the law of cosines, given that we have the side or the side angle side. And then for the next discussion, we'll have the application of the law of sines and cosines and the area of the triangle and the Heron's formula.